I want you to imagine something. Look up at the night sky. But tonight, it's different. Instead of the same old constellations, you see this shimmering, beautiful, absolutely massive cloud. Well, it turns out our entire solar system is about to drift right into it, and what starts out looking like the most incredible light show ever is going to become our absolute worst nightmare. Let's break down what that would actually be like.
So yeah, what would happen? I mean, we've all seen those gorgeous pictures from the Hubble telescope, right? These cosmic nurseries where new stars are born. They look so peaceful. But what if our planet, our home, took a journey right through the middle of one? That's a thought experiment that goes from beautiful to just unbelievably terrifying real fast.
And this quote just nails it, doesn't it? It perfectly sets the stage. That spectacular new light show in our sky, it wouldn't be a reason to celebrate. No, it would be a warning sign, because the very same stuff creating that beautiful glow would also be the very thing that seals our doom.
Okay, so let's set the scene. You gotta remember, our solar system isn't just sitting still. We are constantly hurtling through the galaxy. And in this hypothetical trip, our path is taking us on a direct collision course with one of these enormous interstellar clouds.
So first things first, what exactly are we even talking about here? A nebula, right? It's basically a gigantic cloud in space made of gas, mostly hydrogen and helium, and a whole lot of dust. And while yeah, they're the places stars are born, the key thing to remember is they are not empty. And that density, well, that is what's going to cause all the problems.
All right, so as we start to enter the edge of this nebula, things would begin to change. At first, it'd be kind of cool, maybe even subtle. The sky would start to have this constant, eerie glow. But don't be fooled by the pretty lights. That beauty is hiding a major threat. And the first effects are going to be fast, and they're going to be global.
See, that nebula is just jam-packed with dust. We're talking trillions and trillions of tiny particles. As our planet plunges deeper into this cloud, that dust is going to start to act like a giant sunshade. It would literally block out the sun's light. Think of it like a permanent, worldwide volcanic winter. With no sunlight reaching the surface, temperatures would just plummet, kicking off a brand new and absolutely catastrophic ice age.
Okay, now get this, because here's the insane paradox. While the ground is freezing solid, the sky above us would be on fire. Earth is screaming through space at about 67,000 miles per hour, right? Smashing into a dense cloud of dust at that speed would be like hitting a cosmic sandblaster. The sheer friction would literally set our upper atmosphere ablaze. We'd be living on a frozen rock under a burning, incandescent hellscape.
So, let's just recap. Frozen surface, burning sky. It's a truly apocalyptic 1-2 punch. But believe it or not, that's just the opening act. Because now the very chemistry of our air is going to start to fall apart, setting off a devastating chain reaction.
I mean, just look at this comparison. It says it all. We completely take our beautiful, blue, life-giving sky for granted. But in this scenario, it becomes the enemy. It turns into this toxic, burning blanket that's somehow freezing and incinerating the world at the exact same time.
And here's how that chain reaction plays out. It's a domino effect. First, the dust blocks the sun, and boom, we get a global deep freeze. Second, the friction from hitting that dust lights up the atmosphere. But then comes the third punch. All that dust getting slammed into our atmosphere starts to react with the gases up there, and it begins to systematically shred our protective ozone layer, leaving whatever's left on the surface exposed to deadly, unfiltered solar radiation.
You'd think it couldn't get worse, right? I mean, even if some sliver of humanity could somehow survive the ice and the fire and the radiation, there's still one last, unavoidable threat. It's a force that is slow, it's silent, and it is baked into the very physics of the universe. There's just no escaping it.
And that final threat is called cosmic drag. You see, space is mostly empty, but a nebula is different. It's way denser. Trying to move through it is kind of like trying to run through water instead of air. All that friction creates a constant braking force on our planet, slowing down its orbit. And if you slow down a planet, well, there's only one direction it can go.
And this isn't some quick Hollywood explosion. It's a slow, grinding death spiral. Over thousands of years, our orbit would just keep decaying. Our seasons would get completely warped. Our whole path around the sun would just shrink, pulling us closer and closer and closer to that giant star we depend on.
Okay, let's ground ourselves for a second. Right now, we are in the Goldilocks zone. We orbit at a nice, stable 93 million miles from the sun. It's just right. Not too hot, not too cold, it's perfect for life. You could say that number is our lifeline.
But after just 10,000 years of cosmic drag, that distance would have shrunk by 1.5 million miles. Now, in the grand scheme of the cosmos, that might not sound like a lot, but for a planet like ours, it's more than enough to completely wreck our climate and seal our fate. The spiral has already begun.
And eventually, you know where this is going, over an unimaginable amount of time. This is the end game. The drag just keeps pulling. The orbit keeps shrinking, relentlessly, until the Earth is finally pulled within 1 million miles of the Sun, into its scorching atmosphere. The final plunge. Our planet, first frozen, then set on fire, would simply be vaporized.
So, as you can see, a journey through a nebula is no scenic tour. It's a multi-stage apocalypse that traps our world between ice and fire and the unstoppable gravitational pull of our own sun. It really makes you think and leaves us with one final, chilling question. When you're up against the slow, patient, grinding forces of the cosmos, what does survival even look like?